Sonia, thanks for coming. Hi, Isabel. Again. Hello, how are you doing? There's no what? Hold on. Um. Uh-oh. Let's see. We got a problem. Really? Hold on. Oh, I just sent you the phone. Let me call him. I'm sorry. Let's see what's going on. Hello, we were in the middle. Hello, everybody. We're in the middle of a mystery. Hello. Where are you? We had some people go down to find you. Yes. Yes. Okay. Oh. Oh. Okay. So you'll yes. So you'll call when you're there. Okay. All right. Okay. Okay. 5 minutes. All right. Great. Thank you. Okay. On the loading dock, right by the loading dock. Okay. All right. Great. Thank you. Okay. Bye bye. Okay. We'll send a different group down since you already did your lab. All right. So everyone, today is the day before spring break. So I thought it would be fun to have a little festive thing. So we should have some food coming in a little bit. So if a few of you would go down to the loading dock once the person calls, they left and they said they're coming back. It's just a type of pizza from a father of a person named John. Okay, so it's nothing that special. I mean, it's great. It's special. It's very special. Everyone that's online. Okay. Yes.
Are you gonna make us calculate like the stress or something?
So well, when we were doing those slices for torsion, I got really hungry, right? And I went over to another pizza place that starts with a G, which is right across from the office, and I got a piece of pizza. So anyway, if all of us had shown up the day before spring break, we wouldn't have enough pizza. But since it's a smaller crowd, we'll have plenty of pizza. Okay. But another thing that is not lost on me is that we have a big basketball game today. right now, I think. Is it happening right now? Do you all know? Okay. And guess, do you know who we're playing? Okay, and do you know what their mascot is? They're the Boilermakers. Of all days to get to talk about pressure vessels, our basketball team is playing the Boilermakers. All right? So I also thought that was another reason why we should celebrate. Okay? So we can, and the game will not be over by the time this class is over, which is also cause for us to remain optimistic. That said, Rutgers did actually beat these really talented basketball players. Our really talented basketball players beat their really talented basketball players. Anyway, so today it's session 15. And we're talking about thin-walled pressure vessels. Okay? And pretty much there are kind of the three equations that you want to keep in mind. All right? And they are for cylindrical, pressure vessel, okay, which is supposed to look something. I don't know what this thing is. It does this every now and then. Yep, it's doing it. Okay. Right, so you have a nice little cylinder. And inside this cylinder, we might have some P, some pressure, okay? All right, and then what we care about are what are called the hoop stresses and the circumferential stress, okay? So they can have different terms, but we often think of them as taking a little element and having a long vector here, okay, we'll call that sigma 2, and a shorter pair of vectors for the stress sigma 1. And this cylinder has a radius r and has some thickness. And after the last session, right, we had plenty of conversations about what is thickness. Because when you're doing the beam bending problems, I typically think of height as thickness, right? Like if you have the beam. But when we do transverse shear stress, thickness then becomes the width, all right? So that's like what I normally think of as the B, all right? So if you have BH cubed over 12, then, you know, that width is B, and that's T. Okay, but in this case, it's probably a little bit more straightforward, right? We're saying there's some thickness here, and you know, if this is something like this, right, and the thickness is you know that spot, and sometimes thickness is given as oops, that's the wrong pen, as equal to the R outer minus the R inner, okay? And actually, we usually, when we're describing pressure, okay, we usually think about using Ri as the parameter, okay? And if, you know, you can go through the videos today. This is just kind of a little bit of an introduction. So the smaller quantity, which is called the longitudinal stress, okay, that one, which is going in this direction, you know, along the axis of the cylinder, that has value of PRI, or 1, whatever you want to call it. No, actually, usually we say I, okay, PRI, or PR, over 2T. Okay, and you can see the derivations are in the notes. The circumferential or hoop stress, okay, is equal to sigma 2 is twice, it's double that value. So around the hoop, we are often more concerned. Okay. Hello. You okay on by the loading zone area? Okay, all right. We'll send some people down there in a second. Okay, thank you. Just if you have napkins and plates, that'd be great too. Okay. Oh, okay. All right. Well, it could be a little messy. All right. Thank you. We'll talk to you, or we'll send some people down. Okay. Thanks. Okay. Could a few of you go? Those that did not go before, because they already walked around the whole building once. Okay. Should be at the loading zone. Okay, so if you come out, maybe I should just, yeah, if you go, you know. Oh, wait, oh, you're going to? Everyone wants to leave? All right.
No.
Okay. Yeah, we can. Well, I guess I can't keep going, or I guess we can keep going. All right, so take. So anyway, those are for the two stresses on cylindrical pressure vessels. Why don't you go ahead and you can go to the website and start looking at the material and the notes. And there are 4 questions. You got a question about the other one, right? You wanted to discuss that one? Okay. It's perfectly fine. Okay. So actually, this is you have access to all these notes on OneNote from the website. Does this look familiar at all? Okay. So any questions on this part of it of calculating the shear force? Okay, yeah, so in the problem we were saying go from the right side, okay? If you were looking at the previous exam, it was going from the middle or the support on the right, not the overhang, right? So this system looks something like this, right? And we have this distributed load here. The way the exam solution was set up, all right, was that this was the coordinate x prime. Okay, and so what we were doing is we were saying, let's go ahead and do equilibrium with this system like that. So that's using x prime, okay? And we were in the exam, there was the opportunity to plot the shear force and the bending moment diagrams. Here, since I wasn't asking for a plot of the shear force and bending moment diagrams, and I specifically said go from the right, okay, it's much simpler just to draw this. Hey, how's it going? How are you doing? Good to see you. All right. So in this case, we have the system as such. Okay. So, I mean, it's solved right here. So, does this part of the problem make sense? So, like, if we said we're going, I don't know, this distance here was 0.1, right? All right. Okay, why don't you put it out for people? Okay. So 0.01 meters. Thank you. Appreciate it. Okay. There should be 8 more of those.
Oh, there were like 3 girls who I saw them back there. I think they're coming, but
Okay. All right. Well.
This guy was like not even in the loading dock. He was like.
Oh, okay. Okay, here we. Okay, so, all right, so yeah, take. Yeah. Well, you know, it's spring break. It's spring break, right? And thanks for coming. You missed also the point that there's a big basketball game happening right now. Yeah, a big basketball game. Okay, so we're engineers. We don't know. There's a big basketball game happening with Purdue, okay, and Rutgers, yes, right? And Purdue, the mascot for Purdue is the Boilermakers, and we're talking about pressure vessels. All right, so this is like triple spring break, exciting time. Okay, maybe just double reason. Okay, so. Okay, well, questions on this, on how we found this year?
No, I think it was 10,000 times the 10,000 times the given distance to you, and it was 7
Yeah, so you had to convert cent from cent. Okay, so you got the shear? So like,
So then, yeah.
shear was probably hundreds, right? Or something?
Yeah, it'd be 10,000 times like what 0.022 or whatever they gave you.
Okay, good. So you got that part.
Okay.
Okay, so then the next part was to do this, right? Okay, so we'll get to this in a sec. Okay, so we're gonna jump back, just the introduction. Okay, cylindrical pressure vessel, all right, has this state of stress. A sigma 1, all right, which we call the longitudinal stress, which is PR1 or PRI over 2T, and sigma 2, which we call the circumferential or hoop stress. Okay, and the other one, so there are really 3 equations that we take out of this, and there's more, as you'll see in the notes as well. But these are kind of the 3 that allow us to begin to use our material properties, our compatibility, and other techniques that we've discussed in the past. But these 3 are kind of the enabling ones. So for a spherical pressure vessel, it might look something like this, and we have a P inside. All right, really bad looking. Okay, and on this surface, okay, we have stresses in 2 directions, again, like we had before, and these are equal. So sometimes we'll just say that sigma, all right, or it could be what we called sigma 1 here. You know, you'll see that too. You'll see that maybe sometimes people are like, okay, this is like sigma 1, and this is just PR over quantity 2T. All right. Now go through the derivations are in the notes, okay, and the problems will give you an opportunity to go into depth, okay, into understanding how these equations work themselves out. All right. Great. Why don't you guys get something to eat? I'm gonna get something to eat. I'm hungry, and then I'll come back and we'll talk about this problem. Okay. Yeah. There should be vegetarian options. There should be vegetarian options, non-vegetarian options, and plain options. I knew it was going to be small. To be honest, I didn't realize it was going to be this small. This is very intimate, guys. Well, maybe not intimate. That's not the right word. But it's like a small, nice study.
My first time eating Papa John's.
Yeah.
I'm not
way
just
better than McDonald's.
I thought it was, but like when you get like the garlic crust. Yeah. It's super
Bro, I've never eaten Domino's if I was okay.
Facts. Oh my god.
Yeah. There's going to be.
Bro, this is my
Gonna
first
be-
sesame pizza, that's not Domino's.
There's going to be pizza for you at home. I don't think you're getting through this.
I forgot that pizza didn't suck.
That's true. I'm so used to dining hall food that everything tastes good.
What if the dining hall pizza was pizza on pizza?
Broward. That was Broward. Dave Portnoy.
Hold up.
No,
That's
not
not saying.
saying-
That's
that's
not
not
saying much of anything, but like.
You're doing what? You're defending Broward. That's what you're saying.
Yeah,
It's actually.
That's my head. That's my home, Matt. That's my home.
It's actually.
I go there like twice a day on average.
So
Okay?
I heard Broward has amazing ice cream selection.
That is a very outdated piece of information.
Oh really?
What I hear, I've heard the same, except I've heard that end is like when COVID hit. Kind of disappointing.
I'm so lost. This I would not prefer your.
I will, like, any day. of the week.
Bro,
It's so bad.
And you have the
Yeah, I do. Oh yeah, it's like, I don't even think there's debate.
So
Yeah,
that's
what
Like, Nielsen's good, but it's in
I don't know how long
we changed the formatting.
I got confused. I saw dollar signs.
Yeah.
In my opinion, it's a late night promotion.
I'm just open back.
I haven't tried cooked duck.
I've never even been. I just got here last.
Where?
semester, so I don't really know.
I hear it's good.
I think I know there's one exception, but are you all sophomores?
Yeah,
Yeah,
technically.
kind of.
Kind of.
I transferred, so.
Okay.
I transferred too and I lost credits.
Yeah.
There's so
You
many
could say I'm a
kids like
senior,
that.
but I'm
Bro,
only
rubber
2 extra
stripped
years.
all my credits. They actually gave me credit for a class I didn't take.
I went. What? That is on purpose.
I took like
This is recording. Just be careful.
Never mind.
Yeah.
Plead the fifth. Plead the fifth.
I even took the class after it now, so I don't know.
That's wild.
Well, no, it was like
So
I
you
didn't
learned how many
take
of
the
your
transfers,
transfers?
but
How many of your transfers? Sorry, I interrupted you. Go ahead, Bill.
I didn't take the class. I just don't think it should have counted for the class they gave me credit for because it was a chemistry class and they gave me credit for Gen Chem 1, but it wasn't my college's Gen Chem 1, so I don't know how they gave me credit for Gen Chem 1.
Just take it. You don't have to take chem here. My friend transferred from here to NJIT, and she only took like physics 1A and 1B, and they gave her 2A and 2B, and the labs for that. She got like 10 credits for free. It made no sense.
That's insane.
It made actually zero sense. Yeah, that's what I'm saying. They actually just gave her like 3K.
I got out
like
of
a
physics
semester
class last semester.
there,
so
you're probably 2A.
Yeah.
You were at Montclair.
Yeah. And I took physics. I took physics 1 and 2 and physical applications of something for physics majors. And for everything till 2B.
So is anyone? What's the score? Anyone know the score?
We're probably. I went back, not football.
Huh?
I'm so
Let's
used
go,
to
we're
saying.
right.
I'm so used to saying
We're excited even though we don't know who's up.
Rutgers is up.
Rutgers is up.
Oh.
All right.
When you buy,
We slept in Chrissy.
I'm not gonna lie.
we beat them by 3 last time.
I told my friend to put $20 on. He's in Pennsylvania, so he passed it.
Dude, I have $50 on the Ohio game right now. Yeah. And basically, I got to go to Minneapolis for a week.
That's why you wasn't in class.
Yeah.
Wait, you were.
Oh, yeah.
I was in Minneapolis for the women's tournament.
What part? What were you doing?
Watching.
Headband. Okay.
Yeah. So basically, I was talking to some of the guys who were there and are going to Chicago this week too. And they were like, I don't know what I'm gonna do in Chicago. So I looked up this. No, I looked up this much weird shit.
The river's green.
I created this itinerary for them. Right? So, look at this. Rock and roll, of course, that's a classic. Yeah. Yeah, I guess. The medieval torture museum.
How does Chicago undie river?
Shit, fountain. Important Chicago.
What was that?
I've never actually had
Museum.
Is it any good?
This car covered in concrete. Man with fish. Bro, man with fish. Yo, Matt.
Man with
Fuck
fish.
Man with fish. Chicago. Chicago's #1 spy themed restaurant. How much is spy museum?
Okay. So should we jump to this again?
I also got a negative Q multiple times.
Okay. That's a little bit tricky. Okay. Let's talk about Q. There's a good video by Jeff Hansen. I think my videos are pretty good too. All right, but it's Jeff Hansen. All right, so yeah, so he has a video on what the heck is Q. All right, so the Q is and it's on the website if you want to check it out. All right, but if we talk about how to calculate Q. Okay. Probably the easiest form, okay, is that Q is equal to y bar prime times a prime. That's right. That's right. So if
Our final sucked.
Really?
Our final average was a 40. Like, the exams were easy. And then,
and then okay, so if there's an area like so let's say we're interested in a y prime, right?
she allows us a formula sheet, but it's like, you can't write example problems on it, and you turn the formula sheet.
Okay. So we got this, right? So how do we go about calculating?
What if I just write words?
And in this case, I know it's confusing, but this is what we call
I don't think she'll probably take off for that.
thickness. Okay. So how would you go about figuring out the Q here?
Yeah, if you do that. Because she collects the formula sheet. It's really dumb.
What's that?
Need Y bars.
Yeah, so we need y bar prime.
Which would be H over 2
You know the funny shit during the thermodynamics final?
Y prime. all
She had a list for people who need to use the bathroom. Every time
Okay,
it was her turn,
so I guess I'm not.
H over 4 minus Y.
dude, it was
Okay, so I'm not quite. Yeah, I'm not that fast. I'm not that slick. So let me. Can I just do it the slow way? Is that okay? So I know this height is just h over 2 minus y prime, right? That looks like.
She's like genuinely like a nice person. But, like, she's a bad professor.
Where this is this is recorded. I know this is informal today, but just I
Not bad.
I wouldn't want anybody. Okay.
Not bad.
Yes.
Yeah, I'm not teaching. I was just joking.
All right. So I don't know if it's audible or not, but just we're all on
I don't think so.
candid camera. All right. So do we agree with this? Okay. So that's the height there. So the way I mean, I'm kind of slow here, so I would say it's y prime plus, it's going to be half, right? This is half that height. Do we agree with that?
Oh no.
All right. So then this does come out to be.
And then, oh.
Yeah, this comes out to be y prime over 2, okay, plus h over 4. Okay, so you got that one?
We're gonna have
So how did your q end up being negative?
Well, okay, what would happen
order
is
to
H would be like 11, something around there, and they would give us what Y prime bar was the given, so I rearranged that.
Or not, y bar prime was not a given. Y prime was a given.
I thought that's what it meant by distance.
so we
to the
just
center.
find one of these.
Well, no. So the distance. Okay, so the distance to the centroid is y bar prime, right? But what's given is y prime. Okay, because you're interrogating a particular location, right? So when we look at shear stress, right? We're looking at a v, and q is a function of y prime, right? So the shear stress we're interested in is on. Right, the shear stress is on this, is like at this location. Okay, this is where tau is acting. Okay.
What is simple?
And this is
That's why I was getting the negative.
okay. Well, there you go. That's it. Now, it's possible. I will admit that I made a boo boo. Not on this past one, but on the previous one, it was possible that like I was specifying a point outside, okay, for the bending stress. But for this one, I was careful. I thought I was careful at least to make sure that, because you have an A, right? A is the. Was I careful? I hope I was careful. A is the side length, right?
H or T squared.
Yeah, it's a square. So A is equal H equal T, whatever, right? So yeah, I thought I was careful in making sure that my y prime had to be less than half of the A, or less than the T, right? Because otherwise, you're right, it would go outside. Because the shear stress, right? It's if you're looking at a bar or a beam, right? We've kind of been through this, right? The shear stress, it's max, right, at the neutral axis, and then it goes to 0. On the sides. Okay, if this is the neutral axis.
Oh, you're so right. God damn it. I hate you.
Okay.
I'm like, look at it. Like, that's the
All right. Okay. Yes. Byron. Or Brandon.
So 106.
that's the transverse shear, right? But if I take an element, so let's say I take the element out here, right? And I draw this element.
And then just look at it. Okay, that's fine. 0.26.
Really badly, okay? So that's the element. This, if let's just say that this shear, okay, we're down like this. Okay, let's just say it were, right? If it's down, okay, then the transverse shear is on that top surface. And that is, so this direction is longitudinal. Okay? Does that make sense? Yes. Okay, I. All right, so I, right, is so what is I? Right, so second moment of area. Right. And usually, you know, we don't go all the way back to, you know, you can go and say, okay, I'm going to calculate y squared dA, okay? But usually we don't do that. Okay? What we normally do is look at different geometries that we understand, right? And then we can use the parallel axis theorem with them. So for a rectangle, right? If this is, and we do the derivation. The derivations are actually in the notes for this. Okay, HB, right? The I is going to be equal to BH cubed over 12. Okay. And in this case, often, since these for transverse shear stress, you know, often we have a constant. So T is kind of like this profile. That's what they're, you know, they're kind of like specifying it. Like you could have a difference. It could change, right? So B is usually like this fixed thing that's like the base. But like if it goes hollow, for example, okay, that changes things. So T is supposed to be able to accommodate that change. But if it's a constant full cross section, then we're usually dealing with this I is equal to TH cubed.
So if you're in the thing, it would just be A cubed over 12.
Not A cubed, 8 to the 4th.
Oh, because A and T is.
Right. Yes. So for a square,
Wouldn't it be A cubed? The whole equation because on the bottom is I.
well, let's just do it for a square, right? That's kind of a square, right? If I have this, right? B is equal to A, H is equal to A, so it's just I is equal to 8 to the 4th over 12. The units of this are going to be meters to the 4th, or length to the 4th. They always are. Okay? That help? So that's pretty much, and then T is the width, right? If T is B, right, or whatever, or A, whatever you used here for the side length. So that's how you get the 4 quantities. Okay? So which one do you think was causing the problem?
I think it might have been. I think it might have been the Y prime. I think I was messing all that up.
Okay. Okay. Yeah. Do you? Yes.
It's a little confusing. Robert? Well, like, yeah.
What do I call you?
Tyler. Well, like, if you ever see, like, oh my god, there's no Tyler anymore. So many names. So many names.
Okay. Great.
Okay. Easier. Okay. So, what is So 10 to the 6th, I multiplied that by 10 to the 6th. This one.
Okay, that's for stress. Yes.
And then this one was going to be great.
Oh, that's nice. Okay, so an atmosphere is 450 psi, but you don't want to do that. No, no, no. 40.0. So we're going to be we're going to PSI. We're doing. I do know the temperature you should use. One atmosphere is 101.3 kilopascals.
Do I want it Pascals or kilopascals?
So you can write it in Pascal, but you want it as pascals. Right? So it's going to be 101.3 times
3 times 10 to the negative 3.
no, 10 to the 3 because it's kilo.
Oh.
And then what about liters? Do you know how to convert liters to meters cubed?
Wait, no, multiply by 1,000 because you wanted milliliters.
No, you want it in meters cubed, so you can divide. So you can do the dimensional analysis, but if you have 1 liter, so it gives you liters. What's 10 liters?
Oh,
That number is random. Your liters are random. Your pressure's 10.
Okay, great. Well, you guys know already. I like, there are so many of these that I like put them in, and then I'm like,
Makes sense, yeah.
I
could
remember all
see
of them.
like what would be the fixed value. Like that won't just change every time. Oh, we'll go for round 2. Don't worry.
You're going for round 2?
That was just appetizer.
Don't
Right?
worry. I'll let you know when I see it.
So now the first one, right? You gotta figure out what the radius is. That's the thing that's not given.
Yeah, so I took the. Hey, so what did I do? So should I convert it into meters and not millimeters?
No, it's asking for millimeters.
Oh, we converted everything to millimeters.
I think it's simplest to go to meters cubed.
Okay.
Oh, simpler. It would be easier that way.
Yeah.
You're gonna go to meters cubed, and then you're gonna have to do a cube root.
Yeah, cube root. And then convert it to millimeters.
Why are you converting to millimeters?
That is asking what's the difference in millimeters.
Oh, right, yes, sorry. I asked that. Yeah, because otherwise it's awkward. Because then it's like 0.00 something.
Millimeter to
It's not really. Transverse shear stress, though, like you're saying, refers to the direction along the longitudinal axis. But if I'm looking at the average shear, right on the face, remember we did all those calculations? Right, it's just the force, right, for the single shear and the double shear case. Then yeah, that one's like on the face, right? That's the force, the shear force is like acting tangent to that face. Or on that face, the exact. They are the same, but well, at a given location, yeah, because you have to have equilibrium on these elements. So the specified y prime. Did anyone need their exam? Okay. Yeah, okay. Yes, I have them. I forgot to bring them last time.
oh my god, what did I do wrong? I'm so sad.
Apu. This homework puts me under pressure. I've actually been listening. I have listened to David Bowie and Freddie Mercury under pressure a little bit. So yes, there are all kinds of puns that you guys have been making. This problem is stressing me out. Right? Who said that? Was that Apu? This problem is stressing me out, and because I thought it would only take a moment.
Why didn't you press your computer on that assignment?
That's so dumb.
That's ridiculous. You made it do March 14th, smack dab in the middle.
Okay. Yes. All right.
I don't care if you use that. I'll send it.
All right.
I hope you do this.
Not the best. Because I don't know. I'm gonna actually write this down.
Alright.
So radius, I'm fairly certain I have right.
So you guys don't even watch the videos, huh? No, like look at the notes. Yep. And gathered. So I'm actually.
I watched the videos.
Oh, that's okay. I mean, I think people learn, have their own ways that they want to approach this. And but I'm glad that the notes are sufficiently detailed that you can read them. Hopefully.
Yep.
And get an idea of how they do their problems. Like you'd be listening to some conceptual stuff.
A little later after we piece together our results.
Huh? This class is kind of cool like that because
Oh, no.
pretty much we derive almost everything from scratch. And math
What is
works.
To find the
We gotta find radius. And volume. This year.
Is the R in the sphere equation internal radius?
Yes, so typically the R is terminal radius.
And just because I see the writing on the wall already, if we go into strains, does it measure like a change in radius?
That's part of the question. Yes.
I actually feel the light in the sphere.
Alright.
Thank you.
I'm so lost. R. What's this? That's my conversion from Pascals. Or 10 ATM to Pascal. Let me just. That's like 10 times. If it's like, if it's always 10, like you said, then that's just the number. Like I took ATMs to. What if we just convert Pascals to Pascals? That's what I did. It's gonna be cost. No, but then we just move it.
Can we not just take the cube root of 3 pi?
I did ATM straight to regular Pascal. 10
I feel like it's
ATM
close
straight
It is pretty close. You took a calculator. So I would. So my suggestion, Michael, it is my course in math.
And then since it's 10, just add a 0.
Michael, yeah.
So that's a consistent number.
Stay in variables as long as you can. Okay, for this class.
You said it's
Stay
like
in
multiple
variables.
steps. So it's just like, no, that's just gonna be that. I didn't bother making
That advice was welcome.
Someone made a different kind of circle?
Someone discuss a special circle. A couple special circles.
I thought a circle could be one thing. Oh, times that. There's different types of circles.
I'm
still
You're doing it wrong.
All circles
Actually,
actually.
I just set it up wrong.
Anyone else?
And this is giving you millimeters and meters. This is millimeters. So which G? Times R. Oh wait, let's see. Divided by that.
Wait, what is the radius? Yeah, I know, but what's the unit?
For radius? Meters.
It's meters.
Oh, liters? Oh, one liter is 0.001 meters cubed.
Yeah.
Your radius would be off. I thought that was a millimeter. Like you said, from meters to meters cubed, it's just about that. And when you take the cube root, it just like that out in meters. That's where.
Yeah, like in high school, talk to people on the phone, right? But then in college, it's like, oh, it's kind of fun. We get to like hang out or something.
Struggle together.
You okay? Very emotional up here.
You got it right.
You got it right?
Yeah.
Oh. Oh, you guys like Desmos?
I love these ones.
Oh, well, maybe we should use Desmos.
It's so good. Let's go, Zach. Wait, okay. So this number.
I actually think since Desmos was created, that text
I found out
scam.
Yeah. Okay. I found out Desmos in high school and it since.
Nobody-
Pre-cal, cal, and cal scam.
Not a single person whips out a TI-84 to do anything unless it's a test. It's a scam and they're running it with the schools.
Desmos is so good, bro. I love storing dirt.
After I lost my third calculator that cost us a paycheck, I was like, fuck.
Okay, so what you guys are saying is don't do this stuff in whatchamacallit? Colab not so much, but Desmos is
Sometimes when you do collab, it rarely happens. It happened to me a few times, and then I did it in business, and I got the answer. It was off by like, I want to say 5%, 6%. I don't know. I'm just guessing the percentage. But it was off by like, my numbers were off usually by like 0.5.
Oh yeah, that's happened to me too.
Yeah. It was like every time one of
Like sometimes the code will work for like some numbers, and then like sometimes it just doesn't.
It's like really weird, yeah. 'Cause
Yeah.
I'd run one code, get it wrong, and then run the exact same code for like the new set of numbers, and I get it right.
I have a hard time believing that's not user issue.
No.
Maybe it
I
is.
was like trying to
But
do
I
the
mean,
numbers.
I like you all, but I have a hard time
I was
believing.
looking at the code and I was like, okay, like let me see how this guy did it for the code. And then I ran it, and I could like his exact numbers, his exact setup, and I got completely different numbers than what he did. And then I went and like deleted one variable and I replaced it the same exact way and gave me the right answer.
Again, I would probably suggest there's.
Use
What did
Colab
you
on the
guys-
exam.
No, there's no way we're doing that.
What?
Is there no song?
Oh, there's so much knowledge.
Desmos, no.
What did you guys get? 'Cause mine feels like it's not that you can write for it.
What about making it like a group project? You know, where I'll take it together. You know,
Well,
collaborate.
I love this is
Oh,
this
no,
is
no,
your
no.
group project.
I got
Right.
This is your group project
Yeah.
right
Okay,
now.
I got 3 points.
24% of your grade.
Is that what you use for your scouts?
To
Oh, really?
It is.
Yeah,
It is. This is homework.
Fine.
This is all this.
Oh, yours is
Do you have any
12.
other class where it's worth 24% of your grade?
Yeah.
Wait, homework
Yeah, that's
counts
right.
24%?
Yes.
I did not know that.
Oh, is that just?
Yeah.
It's a slow grind.
I don't know how I missed 2 without realizing it. Now I look back.
Exactly. That's why I told you.
you put it back. Okay. I'm at a loss.
Multiply
So I
this
try to keep you
side
guys
by times the negative g.
Yeah, I have that here.
Oh.
These are all on my side. That's what this is. Dude, I had like a 60% homework just because so many of them I just couldn't do. And then it was too late and they weren't like you couldn't get much credit to me. That's
Have
75.
you missed a class?
My one.
Okay, so can I change this? 12, 112. Yeah, 12, 112, and 86.3. why? Oh, wait. Why is yours 3 over 4 pi? Oh, okay, that's what it is.
Or I forgot
I
the
forgot to
pi.
divide the pi.
Oh.
I multiply. I just moved it over. I didn't divide it. Weird, but I remember.
So
to
if
flip
it's
the other.
spherical,
Yeah, right.
all over two
Yeah,
okay?
you're
And
right.
it's symmetric, and you do the derivation, and they're all. And we'll talk about this a little bit.
Convert
And you
everything.
can rotate the element, and you still have the. It's always the same, no matter what orientation. The case where it's different is when we have
I don't understand units, but I understand cylinders.
So in the hoop direction, all right, the circumferential direction, like the one where you can like wrap your fingers around it, that is over T. Okay, it's twice. It's a big deal. Okay, because it's double in that direction.
Yeah, what is this?
And then in the longitudinal direction, it's over. So like along the line. Yeah, that is.
What was it? Pepper sausage?
Yeah.
Yeah, so if you watch the video, I go through the
I don't know, I
derivation.
think buffalo
It's a
chicken
pretty
is
cool
like
derivation. And you gotta watch the video because it's
Talking
all
about
about
buffalo
bubbles.
chicken.
I love buffalo chicken, but when I want like
That's not
pizza,
a
when I want buffalo chicken on pizza, they're two entirely separate. You know what I mean?
I would always go for buffalo
What's that?
chicken any day of the week.
Nah, dude.
Yeah,
separate
separate.
inside of it.
Like if I go to a
Buffalo
pizzeria,
chicken dude doesn't taste like pizza. It tastes like buffalo chicken.
Spherical bubbles.
it's true, yeah. It's true, yeah.
So I put on bubbles.
Any day of the week.
No, that's true.
But I'm not
Bubbles.
always
I agree. I am more
So,
inclined for buffalo
It's,
chicken than regular pizza.
it's
but if I
not a
want regular
standard
pizza,
diversion to talk about bubbles, but the bubbles turns out the PR over 2T formula.
That's why I just use
the same
matrix.
thing as for the Young-Laplace equation, which describes surface tension and curvature and internal pressure inside a bubble. 100%.
I bet so. I bet so.
Does Desmos let you save?
Put spacing.
Does Desmos let you save files and stuff?
I don't.
Yeah. All right. Maybe I'll use it in the future. I'm not that stubborn though. I am stubborn though in thinking that Python is not speeding up right now. That I am stubborn.
Yeah, you put it down.
Yes.
I don't understand. Question two.
You do this big matrix.
I'm gonna conceptualize. How would the outer ring be? How did the outer one be stressed at all? What would be stressing the outer? Wouldn't the inner one? It's not like the.
Also, I so lied. It's not that hard. I'm sorry. I was looking at the wrong one. Wait, I'm going back to the drawing.
Oh, so
Like a
it's,
delta.
okay.
And sometimes in some treatments people will talk about delta P instead of just writing P, but our P is really a delta. Difference between pressure inside and pressure.
There was something different.
You're gonna need it. You're gonna want it.
Why can't why can't this just be treated as like one cylinder?
bars next to each other.
I so did 6.
We had to use compatibility.
Oh wait, you did 1.3. Oh wait, no, that's right. Okay, that's right. I thought you had 138.
In this case, what we say is the change in radius
Times 2.
of
So
the
then I just
inner
got rid
cylinder
of
is
2
the same
on
as
the
the change
bottom.
in radius
Oh,
of the outer
two.
cylinder. As they're
We both did
right
that.
next to each other. And that interface is pretty
Yeah, but I was like
and the
looking at it,
fitness
it's
is
like you
pretty
multiply the 2 to the stress.
So if you click on that link,
And then you multiply the T, you multiply the
you're
T
gonna
over
really
and
need
divide
that,
the.
because otherwise I don't think you'll.
It's-
I mean,
Like you just,
you
all you do is
can try
multiply
to
the
solve
T
it,
over and divide the
Warlands
sigma.
does a nice job.
It's the same equation, you just replace the T and the sigma. Yeah, I realized I did that wrong too. Wait, what sigma Z is?
I thought they were just the two.
Okay, so sigma z is typically 0. Okay, for any of these vessels because they're thin, and so that's also I also talked about that a little bit in the video, and I cite Roylands. Okay, what happens is you have a P of an internal pressure, right, and then it's a thin wall, and then you have like 0 essentially, or atmospheric pressure. So it goes from a high internal pressure, high internal pressure in quotes, to a 0 pressure outside, and it does it over a very small thickness. And so we say in the material, it's essentially 0. The other way to look at this is we're saying that R over T has to be greater than or equal to 10. Okay, because we're saying that a thin-walled pressure vessel has a large radius compared to its thickness. So if you look at the numbers, right, we have like PR over 2T, and we have PR over T. Even if I say that the pressure in the wall in the Z direction is the same as the pressure inside the vessel, it's still 1/10 or 1/5 of PR over T. So that the stresses that we're calculating, sigma 1 and sigma 2, they're like at least a factor, 5 or 10 greater than
I got it wrong.
So yeah, we typically say that. But the strain doesn't have to be zero. I also talk about the strain doesn't have to be zero. But the stress is
How would the string not be 0?
I think it's wrong. I missed that. I finished.
what happens if you have actually a little bit of bar. What happens? So let's say I have a sigma x. So like okay, I know sigma x equals whatever, right?
Find that one mistake.
What happens though to epsilon y and z? Are they 0?
Stretching.
Yeah, because we have some mixture, right?
I mean,
So for every argument all same thing here. That's what happens. I'm stretching, I'm pulling. It's like imagine like I have a rubber band and I'm pulling it in two directions. It's skinnier, right? Even though there's 0 stress in that direction.
How does that work with the? I get it, but wouldn't the math say 0? Wouldn't the math say 0 if sigma is 0? Because isn't it that function? Or not necessarily function of the thing. No, I was
Pull up the slides.
No, I don't want to shit on you.
No, you're right. No,
Keep
you're
going.
100% right.
I got 15 plus 2.
Keep going, bro.
It is the same.
Yeah. Yeah. It's got the same chip as the back.
That was the.
Yeah, well, no, it should be there.
I got like 2
physics. Give them, tell them like their RUID or something.
No, what's your name? How about start with your name?
What's your last name?
Your name is.
Rajist.
So it starts with an F.
No, his first name starts with an F. His last name is a C.
Yeah. Okay. Yeah. Okay. Let me take a look. I'll see if I can do it.
Continue chatting.
It'd be great to see you in person sometime. Yeah. All right. Okay. I'll see you in the gym too.
That's why you probably need your
You were right there.
No, we're doing that right now.
So, yeah, everyone's not just a composite score. Like you would average something composite. So I'm not gonna do these like modified distributions. You too. Oh, it's time almost. Thanks everyone for saying happy Easter break. How's Rutgers doing? What did you think I said? Oh.
Um, are you guys using streams? Yeah.
Oh, it's like I found it. It's at the very end. Near the very end. You're welcome, Faraz. I'll see you at the final and the second exam. Hopefully sooner though.
Wait, what is?
Oh, he said.
I'll see you at the second exam, the final. Hopefully sooner though. Yes. Oh, Darren. Sorry.
Stress X.
Yes, no. You don't.
That's
You said that we can assume that they deform the same amount.
Did you look at the webpage?
Yeah. Yeah. I should be using strain to detail.
But that's just
Well, actually, they
honestly,
No, number two.
Oh, number two. Okay. Yeah. So okay. So.
I mean, like, apparently you use.
Yeah, there's like
Yeah,
two.
actually,
There's a cylinder and there's a cylinder right around it.
That's not. Oh, that. Oh, yeah, the bladder one. Yeah, the bladder. Bladder one. Okay, I thought you mean the four. The four has two amino acids. Very careful.
Yeah. It's like
No.
Oh, yeah,
No.
okay,
Here,
It
for
is-
number two.
It is question four. It's like put the second one in the line. That's why I said it's like the second one on there, but it's
Oh, okay, yeah. Okay, yeah. Here, so you have two different elastic bonds, right? And so if you look at what Warlines did, okay, and you pulled up that webpage.
yes.
Look at it. Yep. Keep going down. No. There. That's it. Example 2.2.2. Okay. So see, what the condition that we're talking about is that's geometric compatibility, right? We're saying that the radius of the change in the radius of the inner one should be equal to the change in the radius of the outer one.
So this is because I was about to do that in like steps.
Mm-hmm.
I was about to like calculate the strain and then use the radius of the outer one to find the strain and then go work backwards. That seems like a bad way to do it.
Yeah, so the compatibility here, right, and also the insight that he shares is that, look, there's an internal pressure P inside the inner one, right? But there's also going to be a force, another P, acting on it from the outer one. No. There's a compressive pressure, right? So it's like well, it's
And
not
that's
spherical, but
like-
imagine a balloon, right? You have a balloon, bad analogy, right? But you have another balloon around it, right? And it gets harder to blow up. You've got more material.
Tensile strength of the second cylinder. That's the compressive
Yeah,
force.
you've got, well, it's the elasticity of it, it's not the tensile strength, it's the elasticity of the one surrounding it, right? So what happens is you can think of it as kind of a change in pressure. It's almost like you have like a pressure on the inside that will specify, and then there's like a pressure from the outer cylinder pushing on the inner cylinder. Okay, and that's where this P minus PC comes from. Okay, that's the PC is this compressive pressure. Okay, so I'm making sure I got your names. Jack. Robert Taylor L. Tyler. No. Matt.
Spelled exactly like
C-A-R and all these.
Oh no, I thought you were talking about
Oh.
like my last name is literally like Carnal.
Oh.
You've heard of this?
Oh, no.
I think it's more for coding. Yeah, this is actually more for coding.
Wait, it's like a.
Yeah.
Oh, yeah. I didn't know they were called cardinals.
Yeah.
So you're teaching me stuff.
Yeah.
Teaching me stuff. Okay. Michael. Aaron. Vincent. Nisha. Darren. Michael. This works. Brandon. Credit call. Sorry.
Same.
And then I'm gonna lose your names again over here.
At least you try.
Hey guys, thanks for coming. Have a wonderful spring break. Take some, okay, please. And for those of you who are out there in the virtual world, or actually in the real world, enjoying your spring break, have a good one.